everyone. Welcome to math lesson 2.3. We're not going to be taking notes today. We're just going to be working on a couple problems, applying what we've been talking about with volume and about using cubic measurements in inches and units and centimeters and all those fun things. So we're just going to kind of be applying what we've already talked about today instead of taking notes. All right, so I'm working on page 117. I'd like you to go ahead and fill it out with me as we go. I'm going to be marking up my paper, making notes to myself, showing my work, so I don't just have one number in my answer spot, okay, because that's not going to help my teacher know where my thinking was going. All right, so let's start with number 1 here, and I want you guys to mark up your paper just like I am doing, okay? Make notes to yourself, show your work, please. All right, so for number 1, now this one's a little interesting right off the bat because they don't give us any measurements, but it is done with these cubes here. So I think what we're gonna have to do is count up the cubes, find the measurements ourselves, and then apply them to our volume formula. All right, now you'll notice, of course, this is not a perfect rectangular prism. There is a chunk missing right here. So that means I can't just multiply this height times this width times this length, because if I do that, I'm going to get a number that fills up this whole area, and we're missing this whole piece. So, as we talked about in previous lessons, I'm going to divide this into 2 sections. So I see a full rectangular prism here. So I'm going to draw a dividing line there, and it goes all the way along here. So that I'm basically separating that top section from the bottom section. So the bottom section is much longer, top section is a little shorter, but they have the same height. And yeah, oh, and the same length. Perfect, easy. All right, so let's go ahead and measure these. So on our bottom, we have 1, 2, 3, 4, 5, 6. And then on our length, we have 1, 2, 3, 4, 5, 6, 7, 8. And then our height is going to be 2. Okay, I'm not going all the way up to the top here because remember, that's part of the top part. Okay, so they just need to stop right here. So I have 6 and 8 and 2 for that bottom one. So if I put that into my formula, I'll move it down here so because I have a little bit more space. I will do 6 times 8 times 2. All right, let's see if I can work that out. 6 times 8 I know is 48. And then if I multiply that by 2, well, 2 times 40 would be 80. And then 2 times 8 would be 16. So in my head, I'm going to add up 80 plus 16. Let's see, that would be 90 and 6. So 96. All right, so that bottom section is going to be 96. All right, now I'm not done though because I've only done the bottom of this, I don't know what you would call it, solid, sorry, solid. I've only done the bottom of the solid. I need to do the top part and find the total volume of the 2 together because they're part of the same thing. I just divided it to find the volume easier. All right, so now let's find the volume of the top one. So I have a height of 2 again, 1, 2. This time my width is only 1, 2, 3. So width is 3. Sorry if you can't see that. And then our length is going to be the same. If you notice, they don't change. 1, 2, 3, 4, 5, 6, 7, 8. Still a width of, or sorry, length of 8. So this time my numbers are 8, 3, and 2. All right, so since this is multiplication, it does not matter which order I put these in. So I put 3, 8 times 2. If you did 2 times 8 times 3, whatever it is, if you have these 3 numbers, it does not matter the order you multiply, you're going to get the same answer. All right, let's work this problem out. 3 times 8, that's 24. And if I do 24 times 2, well, I already know that. That would be 48. Okay, so I had 96 for the bottom, 48 for the top. I need to add those up to find my total. So 96 plus 48, that's going to be, let's see, 6 plus 8 is what? Sorry, I forgot you guys aren't here with me. That would be 14. And I'm going to carry that 1. Now I have 9 plus 1, that is 10, plus another 4, that is 14. So my final answer is going to be 144. Now keep in mind, they did not tell us what these units were. All they gave us was cubes. All right, so we know that since it's volume, it's going to be cubic. And then since they didn't tell us the unit, it's just cubic units. Okay, so we're going to plug that in here. Our final answer is 144 cubic units. All right, great. Okay, let's move on to number 2. All right, this one looks kind of interesting. Looks like one giant cube with a little piece that's kind of sticking out on the front. Let's go ahead and start with the giant cube. They already gave us the measurements for this, and it looks like we are measuring in inches for this one. See this IN abbreviation all over this solid here. So let's start with the big ones. We have 12 on the bottom and 6 on this side here. So it's going to be 12 times 6, and then the height is 10. All right, and you'll notice on this one, I didn't have to adjust the height or anything like that because this is a full cube with an extra piece coming out of it. This one kind of looked like a full prism that had a chunk taken out of it. And that's why it's a little different when I'm trying to figure this one out. This one, I kind of had to cut these off. This one, I can pretty clearly tell where these two are separated because this part is just kind of sticking out of this prism that's perfectly equal on its own. So I'm just going to do 12 times 6 times 10 because it's a full prism right there. Let me go ahead and multiply that out. So let's do 12 times 6. I already know that fact. That's 72. And then if I just multiply it by 10, all I have to do is move it over to the next place on the place value chart. So it's going to be 72 with a 0, which is 720. All right, I did most of that math in my head. Didn't have to write it out. That's great. Okay, now I'm not done yet though, because I still have to do this other little piece. It may be small, but it's still important. It is still part of this shape. So this piece is 4 by 2 by 3, and they really handily just marked that out for us. We didn't even have to really look very closely. 4 by 2 by 3. Okay, let's work that out. 4 times 2 is 8, and then I know 8 times 3, that's 24. So if I add those up, I'm going to have 744. Now, when I plug this in, they were nice enough to already tell me my measurement or my units. Okay, I know that we were measuring in inches, so it's not just 744, it's 744 cubic inches because we're measuring the volume. The volume is cubic, and the unit we were using is inches, so cubic inches. All right, so there we go. That's number 2. Let's move down to our last one. Question number 3. All right, this one looks like a building of some sort, maybe a school building. And this time we're working with feet, which is going to be the biggest one that we've looked at so far. It looks like we have some bigger measurements too, 40, 15, 15, 10. All right, I might actually have to work out some math multiplication here to figure these ones out. All right, so first of all, let me divide my building into 2 perfectly even rectangular prisms. So I see this top part's kind of sticking out. I'm going to go ahead and divide that part off. Just cut it right off from the bottom. Okay, so that top part is its own rectangular prism, and then the bottom is its own. Okay, let's start with the top part. So it looks like we have this 10 is pointing to the height here. So the height is going to be 10. The length is going to be 15. And the width, oh, it doesn't give me a measurement here. Oh, but it does down here. And it looks like, according to my drawing, these are both going back the same distance. So if this measurement is 15, this one is also going to be 15. So I'm going to plug the 15 in there. Okay, so now I have 10 times 15 times 15. All right. How am I going to do this? I can do 10 times 15, which would be 150, but then I don't know 150 times 15. I can't figure that one out without working it out. So you know what? I think I'm going to do this. I think I'm going to use an area model. I like the area model just because I'm a very visual person. I like being able to see things clearly, and I like them being nice and organized. So seeing area models is helpful for me. So I'm going to take, I already know the 10 is going to be pretty easy to multiply because all I have to do is add a 0 on the end because we're just shifting the place value. But the 15 and the 15 is a little more complicated. Okay, so if I do the 15 and the 15, I'm going to put them on here, but there's something I have to remember. I'm not going to do my area model like this because even though this is a 1 in front, this is still in the tens place. So it's not just a 1, It's a 10. So I have a 10 and a 5. And on this side also a 10 and a 5. Okay? All right, now let's multiply it out. 10 times 10, well, that's 100. 5 times 10, that's 50. 5 times 10, 50. And lastly, 5 and 5 is 25. All right, those are pretty easy. I can add those up. I can probably add those up without even writing it down. 100, 150, 200, 225. There we go. All right, so 225 is what I got for 15 times 15. However, I'm not done yet. I didn't multiply the 10 yet. So as I said before, the 10 is not very hard to multiply. All I'm going to do, slap a 0 on the end there, just moves over one place value. And now that I'm in the thousands place, I have to make sure I have my comma. So my answer up here for that top part of the building is going to be 2,250. That is a pretty big number. We haven't been working with numbers quite that big with volume yet. But this is a building, and we're trying to find the volume of the building, so it's going to be pretty big. All right, so that's the volume of our top part of the building. Now let's look at our bottom. So this bottom part is a lot longer, but it looks like the height is the same. It's still 10, and it looks like the width is the same. It's still 15. All right, so we are going to do the height, which is 10, times the width, which is 15. But this time the length is not 15, the length is 40. Okay, so the length is 40 this time. So again, we have some pretty big numbers to work out here. All right, this time I actually think I might be able to figure this out. I'm gonna save the 10 for last, because like I said, for me that's the easiest thing to multiply. But I have a 15 times 40 here. If I do 15 times 4, I know that. 15 times 2 is 30, times 3 is 45, and times 4 is 60. Okay, so that would be 60, but with another 0 on the end because I'm multiplying by 40, not just 4. Okay, so now I have 10 times 600. That's not too bad. 10 times 600, just 600 with another 0 on the end. 6,000. Okay, awesome. So now I have the volume of my top part of the building, the volume of the bottom part. I'm going to add them up. Looks like we have 8,200. Whoops, I did not mean to put a comma there. Let's take that out. There we go. All right, 8,250. All right, and it's not just plain 8,250 because we were measuring in feet and we just found the volume of something. So it's not just going to be feet. It's not going to be feet squared. It's going to be cubic feet. So I'm going to put my answer right over here, plug it in, 8,250 cubic feet, which I could also write like that. Okay, but either way, make sure we have our units here. It's not just the number by itself. We have to tell what units we were using. So it's 8,250 cubic feet. All right, I hope that was helpful, friends. If you have any questions, please ask your teacher, please, and have a great rest of your day.